TDI is one of the easiest numbers in flexible PU form formulation to turn into a rule of thumb value. After working on similar systems for a long time, many people develop a rough sense of how much TDI a certain type of formula usually needs. But the problem is this: once one key variable in the system changes, the old number may already be wrong. That is because TDI is not a fixed number that exists on its own outside the system. Its required level is essentially derived from the system itself, and that derivation starts with one basic question: how much active hydrogen in the system actually needs to react with NCO? In a flexible PU form formulation, the two main sources are usually polyols and water. Polyols consume NCO, and water also consumes NCO. So when judging TDI level, the first question is not how much you want to add. The first question is how much the system theoretically needs. On the polyol side, the theoretical NCO demand is mainly calculated from polyol use level and hydroxyl value. On the water side, the corresponding NCO demand is calculated from water equivalent. Once these two parts are added together, the total theoretical NCO demand of the system can be established. That is the basic starting point for judging TDI level. But in real formula work, you do not just run everything at a strict 1-to-1 theoretical equivalent ratio. There is another parameter after that, and that is isocyanate index. Put simply, index is the ratio between actual NCO used and theoretical NCO demand. First you calculate the theoretical demand, and then you decide the actual level based on the target of the system. So index is not a fixed rule of thumb number. It is tied to what the system is trying to achieve. This is also why once the blowing rod changes, TDI can no longer follow the old number. As discussed in the previous episode, once water is reduced and MC is introduced, the total amount of active hydrogen in the system changes. That means the total theoretical NCO demand also changes. Under the same index, TDI level also needs to be recalculated. So the real risk with TDI is not that the calculation is troublesome. The real risk is that the system has already changed, but the number has not. If the polyol combination changes, you need to recalculate. If the water level changes, you need to recalculate, and once the blowing rod changes, the old TDI number definitely cannot just be copied over. In the next episode, we will move on to the next question: why can batch form production not be treated as the same as line production? If you want to avoid common misunderstandings in flexible PU form formulation calculation, comment mistakes below. We'll share the document, 8 Common Misunderstandings in Flexible PU Form Formulation Calculation. Or you can download it directly from the link in the video description.